Algebra word problems number 12D. Write self-equations with like terms. This is about ratios and quantities. So, like terms need to be put together. They need to be combined. So when writing an equation from a word problem, we need to keep our eyes open for numbers that are standing alone or a variable multiplied by a coefficient. This is a coefficient, and that's the variable. Once the variable leaves, he's just a standalone number, okay? So we want to make sure you understand that any inverse operation done on one side of the equation needs to be exactly the same operation as on the other side of the equal sign, okay? We want to keep a balance, okay? So Emma is planting flowers in her garden. She's planting half the amount of red flowers than yellow flowers and half the amount of purple flowers than red flowers. If she plants 91 flowers, how many of each did she plant? Oh my goodness. All right, so she's planting a lot of flowers. So let's start assigning our variables, okay? So we use Y for the yellow flowers, R for the red ones, and P for the purple. That'll make sense, okay? And then that way at the end, we'll know which one is which. If we do X, Y, Z, that could confuse us, and we'll say, which one did we use for X? Was it the yellow ones? Or, you know, was Y yellow and R X? You know, so if you keep it so that your variable is assigned to a letter that makes sense, you're going to have a lot easier time at the end, okay? So we know there's 3 types of flowers and that they total 91. So we immediately can say Y plus R plus P equals 91, right? These 3 colors are going to equal 91. Now, it says half the amount of red flowers than yellow. Half the amount of red flowers than yellow. That means the red ones are half of what the yellow ones are, aren't they? If the red ones took up this much space, then the yellow ones would take up the whole circle, right? Now we can also write it, if the reds are half the yellow, that yellow is 2 reds, right? Like 2 halves would make a whole. So we could say that the yellow one is 2 of these, or we could say the red is half of one of these. Either way, it's going to be correct, okay? Now, half the amount of purple than red, which means now we've got the red ones equaling half the yellow ones, and now we've got the purple ones equaling half the red ones. We could also say that the purple ones are 1/4 of the yellow ones. We could say, because the purple ones are half of what the red ones are, we could say they're 1/4, couldn't we? Because this circle could be split into 4s. Half of it is red, 1/4 would be the purple, see? So purple would be considered 1/4 of the yellow. So we could choose which variable we want to use in our equation. You want to stick with the same variable. You don't want to use 3 different variables. We want to compare them to each other so that we're saying we're using 2 y's, we're using 1/4 of a y. You see what I'm saying? So here's what I came up with. I decided to use the R. So the red flowers plus 2 times the red flowers plus half the red flowers equals 91. So because everything was being compared to the red flowers, that the red were half the yellow and that the purple were half the red, I went with this one and this one. These 2 right here, okay? So I've got R plus 2R plus half R equals 91, all right? So now we need to combine the like terms. Now we know there's an invisible 1 in front of that R, right? And we need to add up all these R's. So we've got 1, 2, 3 and a half. 3 and a half R equals 91. So now what do? You want to divide on both sides by 3 and a half. Well, just turn this into an improper fraction by going 3 times 2 is 6, plus the numerator 1 is 7. 7 over 2 is the same as 3 and a half, okay? So by doing this, we can use the reciprocal to multiply to each side. So if you don't remember, to solve an equation with a fraction in the coefficient space, we multiply each side by the reciprocal of the fraction. And when we invert a fraction, we write its reciprocal, like 1/3 becomes 3 over 1, all right? And if you don't remember the coefficient, I was telling you before, it's the number in front of the variable. So when there's a coefficient, and in this place, instead of the 8, there's a fraction, then this is what we do. We flip that fraction upside down, and we multiply both sides by that fraction, okay? So now here we are. We got our 7/2, we flipped it upside down to 2/7, and now we're just going to multiply straight across like we do, okay? 2 times 7 is 14, over 7 times 2 is 14. Well, that just canceled itself out as a 1. So now we got an invisible 1 in front of our r again. Now we've got 91 over 1 multiplied by 2/7. Now normally I would try to cancel out, but I don't know if 7 goes into 91 easily, so I'm just going to let it go and do 91 times 2. I know that 90 and 90 is 180, and then I can add the 2 on it. 182, see? So we know we've got 182 as our numerator and then 7 as our denominator, see? And if you remember, all fractions are little miniature division problems. So this means 182 divided by 7. So I did that. 182 divided by 7 is 26. So that means r is equal to 26. But we're not done. It says that how many of each flower did she plant? So we've got the reds. We still need to do the yellows and the purples. So we know there's 26 red flowers. But we also know that the yellow ones are 2 reds. Remember? The yellows are equal to 2 times the red. So all we have to do is multiply the 2 times 26 and get 52, and we know the yellows. We know that the purple ones are half the amount of the reds. So we multiply a half by 26, and we get 13 purple flowers. Now we know there's 26, 52, and 13 for the flower quantities. See? So sometimes you might have a whole number next to a variable as a coefficient mixed into a problem that's got a half. And then when you see that in the equation it says that, you know, like the red flowers are half the yellow and the purple are half the red, don't let it scare you. Think open-minded that, okay, you know, if the red are half the yellow, well, then that means there's 2 yellows. It doesn't mean you have a fraction and a fraction necessarily. We could have chosen y as our variable, and we could have done half of y, and we could have done a fourth of y if we wanted to. Then we would have had 2 fractions in there, see? So it's alternative ways to write these equations, all right? I hope this has helped you. We're going to move on to the next topic, and hang in there. We'll make it through to the end of this playlist, and you're going to be a professional word problem solver. Bye.